This next method of factoring is a rather popular one, called the difference of two squares, quite simply because we see a difference of two squares. 49 there is the square of 7, and when we break this down, we break it into two parentheses automatically. One will be x plus 7, the other will be x minus 7. And the reason this works is when you FOIL this back together, the x times x creates the x squared, the positive 7 times the negative 7 makes the negative 49, and the middle terms, the positive 7x and the negative 7x, cancel each other out, just leaving these two terms x squared minus 49. Another vocabulary word we use is the word conjugates. We say that these two parentheses are conjugates of each other. Conjugates are not the same as opposites. Opposites would have a negative x minus 7, where we multiply the first parentheses by a negative 1 to get to the second parentheses. Here, it's the middle, sign in the middle, that is different between the two parentheses, which makes these conjugates. And anytime you multiply conjugates together, you get the difference of two squares. So, recognizing in this next problem, x squared minus 64, that 64 is a square, we can write this as x plus 8 times x minus 8. And in the problem beneath this, 25 becomes 5 times 5, x plus 5 times x minus 5. Now, number 4 is not the difference of two squares because 10 is not a perfect square. We could factor it using a square root of 10, but we only use real numbers, and for the purpose of this class, we're going to say that this expression is prime. That doesn't mean that the 10 is prime, it means the expression is prime. Number 5. Don't let this scare you when you see the fraction. 1 is a perfect square, 36 is a perfect square. So we're going to break it into two parentheses. We're going to have x plus 1 over 6 and x minus 1 over 6. Notice that the 1 in the numerator is 1 times 1, and that the 36 is 6 times 6. And that's what gives us these two fractions. Number 6, we see a sum, a plus sign in the middle. The sum of two squares is not factorable. At least not yet using real numbers. So in this problem, we're going to say that the expression is prime and will not factor. And that's important. If you get going too fast, I don't want you accidentally saying, oh, x plus 5, x minus 5. That's what you did back on problem number 3, but not for this one. Number 7. The x squared, y squared, it's okay to have this. Each parenthesis will begin with an xy, and will end with a plus 10z and a minus 10z, just like the other problems. Now, number 8, it's technically not a square square, but x to the 4th is the square of x squared. So I'm going to write this as two parentheses, each beginning with x squared. And notice the first part of FOIL would work. X squared times x squared makes the x to the 4th. We're then going to have plus 4 and minus 4. And many students stop there. But we can't stop there. We have the difference of two squares, and we're responsible to factor completely. The first parentheses, the x squared plus 4, cannot factor further, but the second parentheses becomes x plus 2 times x minus 2. That then is the fully factored expression. Moving on to number 9. Let me straighten that up right. X to the 8th minus y to the 8th. The difference of two even powers. We'll have x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. Now the first parentheses can't break down at all. It stays x to the 4th plus y to the 4th. But the second parentheses is the difference of two squares, so it will break down. We're going to have x squared plus y squared in one parentheses, and x squared minus y squared in the other parentheses. And that last parenthesis still can break down further because it's the difference of two squares. The first parenthesis cannot break down, nor can the second, being the sum of two squares. But the third parenthesis is the difference of two squares, and it can break down into x plus y times x minus y. You always want to try to break down each of these expressions as far as possible, because the directions factor imply that you're supposed to factor completely.